Good day to you, Year 8s. We are continuing on with our lesson on matter. We are today looking specifically at pressure in liquids. The outcomes that you need to be able to demonstrate by the end of this session are the following. Describe the action of pressure in liquids and the Cartesian diver model. Describe how the pressure changes as you go deeper in the liquid. And finally, calculate pressure and forces in hydraulic systems. As usual, before we start, we need to do a few things. Turn off your phone or put it in a different room. Don't have any other tabs open on your computer. Answer all the questions. You may pause the video if you need to. You can always rewind and listen again if you are not sure. And finally, do not give up. As I do now, you need to complete the quick exam questions. Now use a green pen to assess your answers. So the first question was to do with ice. The answers were the following. Ice is less dense than water. And the reason for this is because the molecules are further apart. The second part of the exam questions was to do with oxygen. And the answers are following. A, and the explanation is because there is a low concentration inside the cell and a high concentration outside the cell. And how does this move around? Well, it's by diffusion. Pressure is defined as force exerted over a particular area. There is an equation for pressure, and it is pressure is equal to force divided by the area it is acting over. Now, liquids and gases, this pressure acts over the whole container in all directions. So imagine your can of deodorant. You have a high concentration of perfume particles inside that gas deodorant, and they are trying to get out. They are causing pressure by hitting the surface in all directions. Now we say pressure acts normal to any surface. What that means is pressure is acting at right angles, okay, at 90 degrees. Now where have you heard this term normal before? Have a think. For this section of the video, pause it and try and get hold of these pieces of equipment. Once you do that, you can then do a small quick practical. So the following things are needed. You need one plastic straw, blue tack or a bit of plasticine, scissors, a clear plastic bottle, one that you can squeeze ideally, and glass of water. Okay, let's just test if your diver floats. Now hopefully you have made your Cartesian diver, hopefully you've watched the video, and hopefully we are now in a position ready to answer questions. So first of all, why does the diver float? The answer to that is the density of the diver is less than the water. Okay, so the diver contains less particles compared to the water itself. Also, the diver is filled with air, and we know air is it's not very dense at all, is it? There are large gaps between particles, so that makes the diver even more or less dense than with the water around it. Hence the reason why the diver floats. The question we're going to look at now is why does the diver sink when the bottle is squeezed? Well, when you squeeze the bottle, what you're doing is you are temporarily increasing pressure in that area of the liquid. Now, liquids cannot be compressed. However, gases can. So when you squeeze the liquid in that area, you're squeezing the gas inside the diver. And as a result, the space between the particles inside the gas becomes smaller, so the gas becomes dense. Now, as the gas becomes more dense, it will sink. So then what happens is, if it becomes dense, the volume of the gas decreases, water enters the diver, this increases the density of the diver and the diver sinks. Okay, let me summarise. Squeezing the water means you squeeze the gases inside the diver. This means the diver becomes more dense, so it sinks. Keep it simple. We are now going to look at the question, why does diver float when squeezing stops? So, think about what we looked at earlier. When you stop squeezing the liquid, This stops squeezing the gas particles inside the diver, which means the diver now becomes less dense because the air particles have more space between them, and so it becomes less dense in the water and the diver rises to the top. Year 8, if you need to, for the last, including this slide as well, last 3 slides, if you need to, stop the video and go through my explanation again, feel free, or if you need to read the bullet points, feel free, okay, as long as you understand it. Okay, I've done a lot of explaining guys. What you now need to do is you need to be able to describe what you have just gone through, okay, with the practical, what you saw in the video and the last 3 PowerPoints. So, if you look at the worksheet provided, you'll see the Cartesian diver questions, and I want you to explain and describe what's going on in each of those pictures. Use the keywords pressure, compressed, density, float, sink, water, expands, particles in space. Okay, try and use as many of those words as possible and answer these 3 questions. Why does the diver float? Why does the diver sink when the bottle is squeezed? And why does the diver float when the squeezing stops? So pause the video and have a go at this. Now then, using a green pen, assess your answers and pay particular attention to the words that are underlined in each of these answers. Amend your work as well. Pause the video and do that now. Here are the answers to the extension questions. Again, use a green pen, assess your answers and pay particular attention to the words that are underlined, because these are key points that you need to be aware of and that you hopefully have got your answers. If not, then just pay attention to it and make a note of it. In this section of this session, we're going to look at hydraulics. Now, hydraulics are literally 2 pistons which are connected to each other by liquid, and they work really well because liquids do not compress. The particles in liquids have no gaps between them. So if you compress a liquid, what it does is it transmits any pressure applied to it, and that is exactly how hydraulic systems work, by transmitting pressure. Now we find your hydraulic systems in the brakes of our cars, we find them in the lifting up and down of the forks on a forklift truck, so they are very, very useful. Now the key thing here is, I've already told you, a hydraulic system is literally 2 pistons with a liquid that connects them inside a hose or a tube. If you apply pressure to one piston, you get exactly the same pressure on the other piston. It doesn't matter if the pistons are different sizes, the pressure is exactly the same. Now look at the diagram on this slide. We are on the left hand side, we are applying a force of 1 Newton, which is acting over an area of 1 square centimetre. So the pressure is 1 Newton per centimetre squared. If you look on the right hand side, we have exactly the same pressure being outputted, 1 Newton centimetre squared. Now you can argue, yeah, but sir, look at the force though, force is massive. Look at the surface area, it's bigger. Yes, you're right. So let's look at the force on the right hand side. The force is 50 newtons. The surface area is 50 square centimetres. Calculate pressure. Remember, pressure is force divided by surface area. So the force is 50 newtons divided by the surface area, which is 50 centimetres squared, which means the pressure is 1 Newton centimetre squared. So this is beautiful. We can use a small amount of pressure. Sorry, let me start again. We can use a small amount of force to produce a big amount of force. And that is how the brakes and that is how the forklift truck forks work. It's beautiful. Now, pause the video and have a go at this question yourself. Then unpause the video and now we'll go through it. The key thing to remember with these hydraulics is that the pressure at one end is exactly the same as the pressure at the other end. So, the pressure at X is equal to the pressure at Y. So the first thing you have to do is find out the pressure at X. You have a force of 10 newtons acting on an area of, what is the area? Here we go, 2 meters squared. So 10 divided by 2 gives you a pressure of 5 Newton meters squared. So at Y, you also have a pressure of 5 Newton meters squared. Now, the surface area is 5 meters squared. The pressure is 5 Newton meters squared, which means the force must be 25 newtons, okay? Because to find the force, you have to times pressure by area. So 5 times 5 is 25 newtons. Now what has happened is the force at Y has been increased. So remember what I said to you guys earlier, hydraulic systems are good ways to increase or decrease force depending on what you want to do. Okay, let's have a go at another example. Okay, so here you have a piston X and a piston Y. You've got a force of 25 newtons acting on an area of 2.5 meters squared, which means your pressure is 10 newtons meter squared at X. So at Y, your pressure is 10 newton meter squared as well. Now then, you know what the pressure is at Y, you know the surface area at Y is 7.5, so all you have to do is to find the force is pressure times area, which is 10 Newton meter squared times 7.5 meters squared, which is equal to 75 newtons. Remember, force is measured in newtons, okay? So, what has happened in this situation? Well, because the area is 3 times bigger, the force has also become 3 times bigger. Alright? Okay, this is the third example. We have the same system again, however everything is different. The force on X is 19 newtons, the surface area is 6 meters squared, which means the pressure is equal to 15 Newton meters squared. Okay, remember, pressure is equal to force divided by area. So that's 90 divided by 6 is equal to 15 Newton meters squared pressure. Well, that means the pressure at Y is the same, 15 Newton meters squared. However, the surface area is now smaller. It's 2 meters cubed. So we need to find the force at Y. The force is equal to pressure times area. So that's 15 times 2, which is equal to 30 newtons. Wow. So we started off with 90 newtons and of force, and we end up with a pressure of 30 newtons, which is 3 times smaller. Well, to be fair, that makes sense, because the surface area is also 3 times smaller. Okay? Okay. With this one, pause the video, have a go at these questions on your worksheet, and then unpause the video and then assess your work. Now, there is a question. Why is it that submarines can only go down to a certain depth in the oceans? Why is it that human beings can also only go down to a certain depth in the oceans? The answer to that is pressure. The deeper you go down into the ocean, the bigger the pressure is. Okay? There's a limit to how deep you can go down before the water literally squeezes the life out of you. Alright? Same with, submarines. There's a limit to how deep a submarine can go before the pressure of the water is so big it starts crushing the submarine. Okay? It starts crushing the submarine and busting the seals so that the water rushes in. So, to summarise, the force of water increases the deeper you go. Therefore, divers can only go so deep without a submersible craft. Now, there is a nice little demonstration that I would have shown you in the laboratories, well, the science labs if we were able to be there. It literally consists of a container or a measuring cylinder with 3 different holes at 3 different heights. Alright, so what I would do is I would fill it up with water, and then you would see, you'll see water leaking out of each 3 holes in 3 different ways, such as that shown in the diagram. So pause the video and try and figure out why this is happening? Okay, what is the explanation? So the answer is, as you go deeper, the pressure increases. This is because as you go deeper, the weight of water above is increasing, therefore the force acting on the water increases, so the water that's shooting out of the lowest hole is, well, being shot out further, isn't it? The fact that the water pressure increases as you go down deep affects engineering around you, and it affects, or it leads to certain phenomena. So if you look at this slide here, in the top picture we have a wall, a kind of wall that you may find at a reservoir or a dam. The wall is thin at the top and thick at the bottom. Why? Why is that? Second scenario on the bottom, if you do an elegant dive into the deep end of the pool, you may find that your ears pop. Question is, why? Okay, pause the video, discuss it with yourself or with somebody around you, and we'll move on. So let's go back to submarines. Now, submarines have to dive to great depths under the ocean's surface. You know, when they're on their little secret missions and, missions. Their hulls have to be strengthened to withstand great pressure because they are diving deep in the oceans at times, okay? Whether it is to go underneath an ice shelf or escape other submarines or escape detection. Now, using your knowledge of pressure and particles, can you explain why? Can you explain why the hulls have to be strengthened to withstand great pressure at great depths? To summarise, high pressure can cause a Cartesian diver to sink because it forces the water in, increasing the density. Hydraulics allow us to increase or decrease the force if we change the area, because pressure is always the same. The deeper we go in a liquid, the higher the pressure. This is why dams have thicker walls at the bottom and why submarines have thick, strengthened walls.